Hi students, so today I've taken the topic on center of gravity. I'll be solving a problem on center of gravity. So the question goes something like this. Find the center of gravity of a 100 by 100 mm by 150 mm by 30 mm T section. So understand students, it is very useful. So first let me draw the diagram. So it is a T section, so let me draw the T. So this 100 is, we'll take this as 100 mm, and this total height for this T section will be 150 mm, and the thickness will be 30 mm. So it will be uniform. So this is 30, this also has to be 30 mm. So now we'll try to name this. We'll name it as A, B, this flanges C and D. We'll name it in order so that it will not get confused. E, F, G, H. Is that clear, students? Now before we proceed solving this problem, we should know in which axis is this section symmetrical about. First we should understand what is meant by symmetry. Symmetry means, suppose I'll take this paper itself. So if I fold this paper like this, you know that this is your y-axis, this is your x-axis, this is your x-axis. X-axis will be like this, y-axis will be like this. Y-axis will be vertical, x-axis will be horizontal. If I try to fold this paper like this paper will be exactly matching on this. So we'll call this as it is symmetrical about y-axis. If I fold this paper like this, if it coincides like this exactly, then we say that it is symmetrical about x-axis. Is that clear, students? So now we have to observe this diagram, given diagram. It is symmetrical about what? So here we find that if I fold this, suppose this is your y-axis and this is your x-axis. If I try to fold this figure with respect to x-axis, this shape will fall on this, so it will not be symmetrical about x-axis. Suppose if I fold this figure with respect to y-axis, this portion will match with this portion will merge with this. So this diagram, we say that it is symmetrical with respect to y-axis. This is very important, students. So before proceeding the problem on center of gravity, we should know on which axis does the given, like what is that, rectangles or whatever be the shape is symmetrical. Here we have two rectangles, students. The two rectangles I have named it as A, B, C, H and G, D, E, F. I also have to represent in a proper form, G, D, E, F, or else I can easily call it as D, E, F, G, so that it is easy for us to denote. So A, B, C, H, and we will draw like this, A, B, C, H, and we'll take it in order, and D, E, F, G. Is that clear, students? D, E, F, G. Now what we'll do is we have to take something called as reference, axis of reference. Is that clear, students? For this axis of reference is what we have to do. If it is symmetrical with respect to x-axis, y-axis. So what we have to do? We have to go with respect to this like this. We have to go with respect to this. This is your, so let me draw the symmetry, axis of symmetry. It will be lying like this. So with, if it is with respect to y, axis of symmetry, we'll place our reference line with respect to x. So reference line with respect to x, we have to move like this. So we'll call this as rectangle 1 and this as rectangle 2. You can also call this as rectangle 1 and that as rectangle 2. It doesn't matter. Now we have to move with respect to FE. Axis of reference is FE or EF. Is that clear, students? Now we'll take rectangle 1. Rectangle 1. First we have to find what is the rectangle 1? ABCH. So what is the area of that? Area will be A1. Length into breadth. So 100 mm into 30 will be 1 3s are 3 followed by 1 2 3 zeros. That will be mm square. And similarly, now we'll have to find y1. I told you how to find y1. You have to be careful here. You have to move like this with respect to this. From here to here, this is x-axis as a reference. We'll take the, it is symmetric about y, so we'll have only y1 and y2. For this it will be y1, for this it will be y2. So we only move like this from here to here. This height we have to find first. We are concentrating on the first rectangle. So this height will be 150 minus 30, which is 120. So y1 will be 150 minus 30. Then again this particular distance, this distance is 30. So half of that, it will be lying, center of gravity will be lying with respect to half of that. So 30, 120 plus 30 by 2 plus 30 by 2. So, or you can also take y1 equals 150 minus 30 by 2. How you got that? 150 is the total and 30 by 2 it will lie here. So 150 is total, minus, if you do 150 minus 15 will be here. So it will be with respect to this. Instead of going like this, you follow this. This is easy. So what it is, you have to go with the first one, which is very simple. Let me not confuse you. So what you will do, this distance is 150 minus 30 will be 120. 120 plus half of this 30 by 2, which is 15. So y1 will be 150 minus 30 is how much? 120 plus 30 by 2 is 15. 120 plus 15 is 135, which here also you will get 150 minus 15 as the same answer. 150 minus 15. So we'll stick with this. We'll go with this. That is mm. Similarly, now we'll go with the next rectangle. That is rectangle DEFG. Here, what is the area? Area will be A2. So here we will take it as length into breadth as 30 by this one, 30 by 120 or 120 by 30. This we can take length and this as breadth. 120 by 30 equals 12 3 is 36 followed by 2 zeros. 2 zeros mm square. Now similarly for this one, y2 will be, how will you take y2 with respect to this? FE will move like this. It will be half of this. This will be 150 minus 30 is 120 and 120 by 2. So I'll write 150 minus 30 by 2, which is 120 by 2 equals 60. 120 by 2 equals 60. I'll write like that. Y2 equals 60 mm. Now we have the formula for center of gravity of the section between the and the bottom flange. FE will be y bar equals, it is given as A1 y1 plus A2 y2 upon A1 plus A2. That is the formula for finding the center of gravity. So when you just substitute, it will be A1 equals 3000 into Y1 equals 135 plus 3600 into 60 upon A1 plus A2 is 3000 plus 3600. So how much you'll get? That will be 3000 into 135 plus 3600 into 60. First I'll do the numerator. That will be 621 followed by 3 zeros, 621 followed by 1 2 3 zeros divided by 3000 plus 3600 equals 6600. So final answer will be 621 triple zeros divided by 6600, which is 94.01. So we'll round it off to 94.1 mm. That is the answer, 94.09, which is equal to, we'll round it off, 94 mm. Is that clear, students? This is how we calculate the center of gravity of the given T section. So keep subscribing to my channel. So I'll be also ensuring that I'll be posting more of the videos so that it's be helpful for you, and it has to be like, you should be like feeling happy. And in case of any doubt with respect to any step which is not clear, don't forget to ask me in the comment section. I'll be waiting for you. So do like, do share, do comment, and keep loving, sharing, subscribing, liking, commenting, and subscribe. And do, I need your love. That is most important. Okay, students. So if I want to have to just do a easy steps or method to make it very clear, you have to just assume 100, 150 and 30. First one, this is 100 and this will be 150, not this much is 150, and this is your 30 for this particular T section. This is one rectangle, this is another rectangle. You have to know it with respect to what it is symmetrical. So we found that it's with respect to y-axis, so it will be y-axis with respect to symmetrical. Then based on that, with that reference as x-axis base reference, you will move like this. Then A1 will be this area 100 by 30, and y1 will be this distance plus half of this distance, 150 minus 30 plus 30 by 2. Then similarly for DEFG second rectangle, you will find 30 by 120 or 120 by 30, and y2 will be this distance. So you will not consider this. So with respect to this, 120 by 2 directly also you can write. Now y bar will be A1 y1 plus A2 y2 by A1 plus A2. This is the formula for finding the centroid. If you just substitute, you will have 3000 A1 into y1 is, this one value is 135 plus 3600 into this one value is 60. If you multiply these two and separately and these two separately and then add them, you will get 621 000 divided by, when you add both the areas A1 and A2, 3600 plus 3000 or 3000 plus 3600, you get 6600. When I divide 621 000 by 6600, you get the centroid, center of gravity of this particular T section lies at 94.1 mm from the base. That is very, very important. Thank you, students.